Just tell me when you hit record.
It's recording.
Hello, my dear students. This is an experiment, a video experiment, and though this is a chemistry course, this is not so much a true chemistry experiment as an experiment in our adaptation to our COVID-19 quarantine protocols that requires that all of our courses for the time being move online. And being a little inexperienced and just today getting the iPad working thanks to my wife and videographer Tiffany, we are trying to get a video prepared and posted to the course so that in the near future, in other words later today and tomorrow, may post some video lectures and some video labs. And of course the first lab we'll do is the lab we're in the middle of, which involves examining some of the elements in the periodic table and their properties, including what sorts of similar reactions they carry out with some polyatomic ions, specifically sulfate, phosphate, and I want to say carbonate. I don't have the protocol in front of me, but I will. And one of the things that affects both reactions, solubility, and rates of reactions is temperature. And the experiment calls for us to boil some water and put our tubes in there. So, if you look around, you will see I am in my classroom here at Dumas High School. It's a wonderfully equipped science lab with everything we need. And of course, if we're going to do a lab, the first and main concern I have, and that's a concern shared by your administration here at CR College, is for your safety. That's why we're doing a video lecture. This is why I'm learning and experimenting with how this is going to work right now. And this is why we're not in school, because I can assure you, I've talked to President Bloomberg many times, as a faculty member, as an adjunct faculty, and as a dean working as part of his administration, that the number one concern that he has all the time is for your safety and your well-being. And so, I'm going to put on my lab coat, and we have safety glasses and safety goggles in the cabinet, but me being an instructor and using them all the time, I don't need to sterilize mine between uses. I use my own pair all the time. So, can you zoom in a little bit? What I want to show you is how to light a Bunsen burner and how to boil water. And what we'll do later is finish our experiment, and I will have copies of the lab. I don't know about doing any video editing, but I will attach in similar files copies of the lab with explicit instructions on where to record the data that I'm going to demonstrate how you would have done it if we could meet at school and perform our lab. But this is a poor second, but I hope it'll be okay. So we've already used a Bunsen burner when we were doing the flame test from our different elements and exciting those electrons, getting them up to a higher energy level, and as they decay, they shed that excess energy as heat and light. But thanks to the quantum model of the atom, it's not just any light, it's very specific wavelengths and frequencies of light that correspond to very specific energies. So remember, those electrons move up in steps. They cannot ramp up and go slowly up like a ramp. They have to go up stepwise into their different energy levels. Well, let's have a little more instruction just as a way of experimenting with our burners. So, there are many types of burners. This is a Bunsen burner. This is technically a Terrell burner, but it is very similar to a Bunsen burner except that it is adjustable. The flame is adjustable with a screw at the bottom, and the air mixture, the fuel-air mixture, is adjustable by opening and closing this gate at the bottom by screwing the chimney up and down on it. Now, this is a Fisher burner. You'll use these in microbiology. And when we light our burners, you can use a match, you can use a big lighter, preferably one of the extension lighters, but we traditionally use a striker, the same thing that's used in welding. It consists of a flint that is rubbed across a metal plate so to provide a spark to ignite the gases that you capture in this bell cap. So to light the Fisher burner, you turn the petcock all the way on. Don't try to adjust your gas flow here. These don't give good control of the gas flow. We will use the valve at the bottom of the burner to adjust the gas flow. You hold the striker over, you turn it off here, we will hold the striker over the burner, capture some gas in the bell, and light it, okay? That's a Fisher burner, burns very hot, has a big broad flame, and is wonderful for a variety of uses in the lab. But today we're going to use something more traditional like a Bunsen burner. This is technically a Taro burner because of its adjustability. I'm going to turn the gas on at the petcock. I'm going to hold my striker, the bell of the striker, over it to capture the gas, and I'm going to spark it. And you can see I can adjust here and adjust the level of gas and the fuel-air ratio. And what I want is a cone of flame, a blue inner cone, and that's the hottest part of the flame, and the tip of the cone is where we're going to do most of our work. But today we're just going to use this burner to boil water. One of the problems with boiling water, and I'm going to turn this off, I'm going to turn it off completely by twisting the petcock so it's perpendicular to the flow of gas. This way the gas is flowing out. I turn it off not by blowing it out, not by snuffing it out, but by turning off the gas supply. So, one of the problems that we have is that I use ultra-pure purified water, and I clean my glassware very well. And it is possible to heat the liquid up above 100 degrees so that when this water has been heated up above boiling and it doesn't boil, that water will be superheated, and the smallest bump will cause it all to boil out at once. Extremely dangerous and something we want to avoid. So in every lab, we use one of a few things. One of them is boiling chips, and another one is glass beads. Excuse the bell. So, I thought I had my glass beads out. I don't see them, but they're just small, clear glass beads. And in my past, I have also just used plain old marbles from Dollar General to provide additional surface and places for the gases that are being driven out of the water, or for the water vapor itself that's being generated from the heat to nucleate, form a bubble, and escape. One of the best things to use, and something that's been used for centuries, is marble chips. Limestone chips, also known as calcium carbonate, also known as boiling stones. All these are small chips of marble. Here's an old one, marble chips. Here's a new small one, marble chips, also labeled limestone, also labeled calcium carbonate. Here's one from Frey Scientific, labeled calcium carbonate, but in fine print underneath, it's marble chips. And if you touch them, you have to take them. You take a few chips out, like so, and you drop them into your beaker. So, what I'm going to do is take my beaker, and even though we use good borosilicate glass with a low coefficient of expansion, that is safe to heat. We don't want direct heat on it, so we diffuse that heat with a wire gauze. Sometimes you'll see these impregnated, some very old ones, which you should throw away, with asbestos. The modern ones are impregnated with ceramic. This is just a plain wire gauze that hits that heat and spreads it out so it heats the bottom of the beaker evenly. I have built-in stands, and I have rings on them, or I have what's called a ring stand with a ring on it. This one's a little more flexible because I can move it to any position on my bench. And what I'll do is move my burner under my ring stand, give myself, between 5 and 10 centimeters of distance. That's a little high. Let me get it back down in the 5 range. And I'm going to light my burner. And you'll see the wire quickly heat up to red hot. And I have a flame. Anytime I'm working with flame, once again, safety, I know where my emergency shower is, although I prefer it be used for chemicals and not chemical spills and not putting out fires. I would hate for someone to run to it and fan the flames, and I know where my safety fire blankets are in the lab and how to access them before I do anything with fire. Now, this is very hot, and if I put my beaker on there, I'm exposing myself. My hair is tied back, of course, if I had long hair. I'm exposing myself to fire and flame, so I'm going to use beaker tongs. And I'm going to pick up my beaker with the beaker tongs and set it on top. And this is very hot. It will very quickly boil. While we're waiting for that to boil, let me tell you about the striker again. These strikers do wear out. The flints are being worn down every time you strike them. And if they wear down to this metal here, it's very simple to screw that off, take a new one. They sell packs of 5 for about $1. Put it in there, and it's usually good for another semester or 2 of student use. I pop it back in under the bell cap, and now it's sparking beautifully and is perfect. I'm going to heat up this water and boil it. And when we do this experiment, one thing we'll be doing is boiling our test tubes in there. Now there's a problem. How do I put my test tubes in there without burning myself? So let me get a test tube to demonstrate. Okay. I'm going to say this way. We'll be using 10 by 75 or 10 by 100 test tubes like these. And so that we don't have to, I'm going to walk around the back of you. So that we don't have to get ourselves too close to the flame, we're going to use a test tube clamp. A very simple device that keeps you an extra 3 or 4 inches away. Now I can set that tube in there. As that water boils, I can get it out, or I can set it in there and leave it there. And if you don't have too many tubes in your beaker, one thing you can do is take 2 of them together, span the beaker like so, and keep your tube suspended and upright in the boiling water. If you're going to boil a large sample for a long time, your water from the outside will heat your substance from the inside and boil it. And one thing you can do is capture that by putting a marble on top, and that will allow the evaporating or boiling substance inside to condense on the marble and drip back down and save your volume of any sample inside. You may not be able to tell, but this is starting to boil at the bottom, and because we have boiling chips in there, we don't have to worry about bumping this and having our whole contents come out. So we're going to finish our lab, and when it says place the test tubes in a boiling water bath, those are the steps you need to take. Those are the considerations you need to make, especially for your own safety. And as ever, if you have any questions, feel free to ask. If you look, it is now boiling vigorously. We can control the rate of boil by turning down our flame, pulling our flame in and out, or by moving our whole ring stand up. But it said to boil for several minutes, and that will be fine. I'm going to turn my burner off at the petcock. Don't blow it out like a birthday candle. And you can see it's still boiling. And one thing I'll warn you of is when it stops boiling, that doesn't mean it's not hot anymore. I can't just look at water or glass or steel and tell if it's still too hot to touch anymore. Obviously, if it's red hot, it's too hot. Obviously, if it's boiling, it's too hot. Obviously, if it's steaming, it's too hot. But right now, this is very difficult to tell which one's the inside and which one's the outside. There we go. To tell if it's too hot to touch or not. I'm going to always assume it's too hot. At this point, I would put it into my test tube rack here. Set it aside for observation. That's exactly what we're going to do, is observe and see if we still have a precipitate, a solid that is formed in there. And then, this is still hot. Maybe I want to take this down to so that it's unlikely to get knocked over or tip over. It is top heavy. I'll set my burner aside, grabbing it from the hose, knowing that the chimney and the tip are probably hot. I'm holding my beaker with my beaker tongs. I know it's hot because I just saw it boiling, and I also see steam coming out of it. And I'm going to set it down. I have stone tops. You don't want to set it down on top of something that it may damage if it's too hot. And I'm going to leave this, ring stand, ring, and wire gauze to cool down for later. So, this was your first video lecture. I apologize for the inconvenience, but I'm glad I'm not coughing on you and you're not coughing on me. And I really hope you all stay safe and never hesitate to contact me. We'll keep you caught up, we'll keep you informed, and we'll keep learning chemistry as much as we can. That's it. Goodbye, my dear students, and I will see you in the next video. Bye now.